This video is on the distance formula. As you saw in the Unit 2 applications and in the Carnegie workspaces, the distance formula is based on the Pythagorean theorem. The Pythagorean theorem says that in a right triangle, the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. So for example, in this triangle here, A and B represent the lengths of the legs of the triangle, and C is the length of the hypotenuse. So A squared, the length of this leg squared, plus B squared, the length of this leg squared, equals C squared, the length of the hypotenuse squared. Given a segment on the coordinate plane that is neither vertical nor horizontal, so we're not going to worry about distance when it's a vertical segment or a horizontal segment because we can just count. We can draw a right triangle in which the segment we're interested in is the hypotenuse. So for example here, my segment is AB, and notice that it is not vertical or horizontal, it is slanted. So I can draw this vertical segment and this horizontal segment to create a right triangle. We can then calculate the lengths of these vertical and horizontal segments, the legs, by taking the absolute value of the difference of their x and y coordinates. So the length of this vertical segment is going to be y2 minus y1, where y2 is the y coordinate of B and y1 is the y coordinate of A. We can do the same thing to find the length of this horizontal segment by subtracting x2 from x1. And we always want to take the absolute value to make sure that it's a positive number because distance is always positive. We can then plug these lengths into the Pythagorean theorem. So the length of the horizontal segment is the absolute value of x2 minus x1, and we square that since that's a leg of the right triangle, plus the length of the vertical segment, y2 minus y1, the absolute value of that squared because we're going to square that. We add those together, that equals the length of the hypotenuse squared. Now notice that in this case we really don't need the absolute value bars. Remember, the absolute value bars are going to make that difference positive, but squaring that distance is going to, or squaring that difference is going to make it positive as well. So we can actually write it like this. The quantity x2 minus x1 squared plus the quantity y2 minus y1 squared equals the length of AB squared. Or if we take the square root of each side, we have that the length of AB is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. This is basically the distance formula, which is more formally written like this, where d equals that square root, where d is the distance between the points x1, y1, and x2, y2. So let's try one example here, where we're going to find the distance between the points -1, 3, and -5, 9 using the distance formula. So I'm going to calculate this by saying d is equal to the square root of x2 minus x1, -5 minus a -1 squared, plus y2 minus y1, 9 minus 3 squared, and I take the square root of that whole thing. Now I just use order of operations to simplify. That's going to be the square root of -4 squared plus 6 squared, which is the square root of 16 plus 36, which is equal to the square root of 52, which I can actually simplify and rewrite that as 2 square root of 13. So in this video we took a look at where the distance formula comes from, the fact that it's based on the Pythagorean theorem, and then how to use the distance formula to find the distance between two points when we're given their ordered pairs.